Right, good morning again, everyone. It's my great pleasure to be able to introduce our second speaker of the second session. Minyoung Rho is from Oxera Consulting LLP. She's going to be talking to us about data science in economic consulting, various use cases in regulation, litigation, and more. Her background is in economics from an academic perspective, where she worked on using economic theories to build model structures and to parameterize counterfactual analysis. She's now working as a data scientist and is merging statistical and economic tools to glean actionable insights. So over to Minyoung.
Thank you. So today, can everybody hear me okay? Good. So today I'm going to talk about how, like a reflection of a data scientist from an economic consulting perspective. So at the beginning, I want to talk a little bit about our firm, just to have a short plug. We're an economics consultancy. We just had our 40th birthday last year. And then we have a reputation for having integrity, analytical, and independent analysis for a lot of use cases that I will be talking about later on today. We have a very particular mission where we're economists, and we are using economics, finance, and data science to make better decisions. What that means is to help solve complex challenges or to build great strategies or doing a robust analysis. We are European consultancies. We have offices in Amsterdam, Berlin, Brussels, Hamburg, all over the place, Milan and Rome, if those of you who really like Italy. So come talk to us afterwards if you're interested. And we do have outputs in a very, very specific format. And I'll talk about it for the rest of the talk. So how do we use data or data science in economic consulting? So economic consulting refers to a specialized field where we economists apply economic theory, data analysis, quantitative methods, and provide expert advice and analysis to various stakeholders. So there's three key areas that I think that we work the most on. One is on the litigation support. What that means is that in a court case, there needs to be a calculation about how much the damage has been done, for example. In which case we go in and we analyze what the damage is using economic models or sometimes data science models. And then there's another side of experts who are doing exactly the same thing on the other case, because the litigious process is very competitive. So two expert opinions are coming in together to figure out which model is more truly representing the market and then the situation there. So we do a lot of those. Quite intense process. I really love that process because that keeps me on my toes. It's a really fun process to do so. We also provide support on antitrust and competition. So what that means is if there's any level of market failure where it's harder for an entry of the market or if the consumers are being harmed, we need to do the analysis. What is the extent of the harm to the consumers? What are the impact of any of those anti-competitive behaviors? And we go into that. And today we're going to talk about a merger case and a cartel case. So hopefully that'll be fun. And then the last area that we work a lot on is a regulatory setting. So in an area where market failure has been detected, and what I mean by market failure is it's not competitive. Anything that is not competitive market is considered as a market failure. So if there's a monopolist, like a natural monopolist, I think a lot of you took a tube today or train today that is natural monopolist. There's no two train companies who's driving in the same route. So those cases, technically, they can charge you any price they want. So there needs to be some regulation that needs to be there. Then how do you set the prices? And I'm happy to talk about it a bit more. We don't have a use case today, but I'm happy to talk about it outside during coffees and lunches. So because this is a data science conference, I thought we could do some keywords to connect what we do every day to what data science use in terms of their keywords. So we do a lot of causal inference, because we do have to explain a lot about how this model is developed. So what that means is data generating process is very, very, very important. So a lot of the models that we build, we need to know what's going on. Yes, there could be some machine learning or there could be some pattern recognition, but it's very important for us to know, identify exactly where that comes in and where other things come in. So understanding the model with interpretability is very, very important. A lot of the cases, we actually need to use what's called counterfactual. Because, for example, so a lot of the cases that we're going to look at, first case we're probably going to look at is the merger case. We don't know what is going to happen when they merge. So we need to think about and counterfactualize if the two firms were going to merge, what will be the market setting. So we do have to build a model that actually does counterfactual scenario in a very robust way to be able to take it to the court and then say this is what's going to happen in the future. So counterfactual is a very kind of common concept in our offices, so you always have to think about counterfactual. The other thing is replicability. I think that's probably what it sets us apart potentially the most, where it is a court case a lot of the cases, which means you have to take it to the court and they need to be able to replicate it. Or if it is a merger case, the authorities need to be able to replicate. So we have a very, very standardized format about how all the models needs to be written down. The code has a very, what we call Oxera house style format that needs to be written very, very clearly and very prettily. So replicability is very, very important. Interpretability, again, huge job of ours is actually explaining this to the people who are non-economists or non-data scientists, who are authorities, stakeholders, companies, and all of those. So we do have to do a lot of those. And we use econometrics a lot for these reasons that described. So because the data generating process is so important, sometimes we do have to make structural assumptions about how the price is being set. And the best way that I have figured out in terms of modeling that part is actually using economic theory. So econometrics comes in a way that, yes, data can probably recognize a lot of the patterns, but if we need to put some structure around what that pattern is, we often go back to economic theory and then use that and then parameterize those economic theories and then get the parameters out using the data. So that's what we're doing a lot of the times. So I have 3 examples today. We have a lot more, but I only brought 3 because of the time. I also brought 3 that are publicly available. A lot of our work is actually what we call strictly confidential and legally privileged. So we can't talk about a lot of those things. So I brought 3 cases that are online, public, you can look at it. So I brought the sources down. So if you want to look at the cases, you can look at these are not particularly the one that we worked on, but we can have very similar cases. You will get the sense of what's going on, but a lot of our cases, we can't really talk about it publicly. So let's think about a merger case. So let's imagine a scenario where 2 mobile device makers are going to merge with each other. Again, this is a very theoretical case. So let's say Samsung and Apple are going to merge with each other. Then what's called competition authority, this is a regulator, what we call government. The governments are really concerned about a few things. First one is, once they merge, they're going to have a really, really high market share. What that means is they're going to have higher market power. They can charge whatever they want at that point, probably, and then that's going to be very harmful to the consumer like us, who's going to buy the device. There's also a kind of relatively indirect effect, which is lowering competition could mean there is a less innovation in the field. So the small firms who are hungry to go drive the innovation, it's really going to be hard to enter that into the market. But recently, actually, the innovation and the research and development has on another side of an argument where the bigger actually could have a larger investment pot. So both of those things need to be considered, but this is a classical argument for having a market power. So impact of our work is going to be, if our analysis is convincing enough, it could influence the judges or the competition authority's decision to block or green light the merger. So it'll actually be driving, you'll see it on the news if something happens. So I brought a very specific analysis or model for this particular case. There's a lot of other models that we could use, but we particularly are using something called closeness of the firm. So when the competition authority thinks about, should I say yes or no to this merger, one of the things that they need to think about is, are they really close? Another way to think about it is, if those 2 merge, where are these consumers going to go? And how are they going to buy? What is the price that they're going to buy? So closeness of the firm is one of the analysis that we need to do. So then, there is a formula called diversion ratio, which helps firms to estimate how much business might gain or lose if they change the prices. So, in a nutshell, diversion ratio across all the competitive products has to sum up to 1. What that means is if I raise my price, I'm going to lose some consumers. Where do they go? Do they go to Apple or do they go to some other firms? So they calculate percentage of the customer who's going to go to your competitors. That's what diversion ratio is. So in a nutshell, if the diversion ratio is high, that means consumers are likely going to switch to your product and the other way around. How do you estimate that? There's 3 big steps. First, you need to estimate the demand. This is what we call data generating process, how the consumers make choices. If you don't know how they make choices, you won't know counterfactual scenario. When the price goes up, they're going to switch their behavior. What comes out of that is called price elasticity. I'm sure you all know, if you increase the price, you're likely to lose customers unless it's a luxury good. The last thing is using this price elasticity, using this data generating process, we plug it into this diversion ratio formula to figure out what percentage of my customers are going to go to a competitor if I change my prices. So let's think about how to estimate demand. A lot of the cases that we deal with is like a differentiated goods market, which means that it's not commodity. It's not gas, it's not water, you're gonna have a different features. The reason that you're buying Samsung phone versus Apple phone depends on the brand, depends on the prices, they have different screen sizes, they have different processor speed, all of those. Another thing that we are looking into here is that it is a discrete choice market. What that means is you have set number of choices at each period and you're competing against each other. You can always say, no, I don't want to buy, it's called outside option, but you have to choose among the set number of products that you have. So this is what it looks like. In econ theory, this is called randomized utility function. What that means is for person I, each product, so if I look at Apple phone versus Samsung phone, I have something called utility. If I buy this phone, how happy am I going to be? That's going to depend on the price. Cheaper it is, the better for me, normally. So the alpha over there is normally going to be negative. If I have a larger screen size, am I happy with that? Some people like larger, some people like smaller. That's going to depend on your preferences or your utility. If you have a higher processor speed, my guess is normally people will be happy with that. And so all of the features about that particular product is going to go into that X there. And then there's some brand valuations. The brand also goes there as a 0 and 1. There's a bunch of data that you can put it in there. And there's also called unobserved characteristic. So because we see the same people over the different period, you get to see what is not captured by this X. So over the period, if they're making the same persistent decisions, you get to see what their preferences are for that particular product. Then, how does this get matched up to the data is by using the market share. Because transaction data is really hard to get. And if we get it, we can plug in right in. But a lot of the times what we get is a market share data for all the products. So the market share, if you do an analytical interpretation of the logit model, or what we call mixed logit model, then the market share can be equated into these ones, which means we can get all the Greek letters out. How much do you like about the price? Are you price sensitive? Or do you like larger screen size? All of those can be estimated out. I don't think I'm going to talk about instruments, but because data generating process is important, for those of you who had an economics background, we do have to consider something called endogeneity problem. So price affects how much you buy. How much you buy is going to also affect the price. So there is so for those of you who are in causal inferences, there is this simultaneity problem. You always have to control for that. We normally use instruments to do that. There are a set of instruments that we use, but not the topic of today's talk. So at the end of the day, what we have elasticity. So what this graph is, I'm going to go over here. There's more people here, so I'm going to go here. So you have 0 to, so you have about 25 products. And this is how price elastic. So if you change the price of the first product, how much are you going to change your demand for the other product or your own? So this diagonal will be your own. So if I increase my own product or price, then you're probably not going to buy as much. Is general assumption. I know there are cases that doesn't happen, but let's go with me for now. So normally this diagonal will be negative, but if I actually increase my price, setting everything equal, your competitor's price are actually going to, so your competitor's product is all of a sudden going to be more attractive to you because they're cheaper compared to me. So off diagonal will most likely be positive. It's very low positive, but it'll most likely to be positive, and then diagonal is most likely to be negative. And that's what you're going to see if it's a normal good. This changes if you have non-normal good. It's getting harder, but we're going to look at this normal good where if it's cheaper, better for you. So elasticity is very important, but the ultimate outcome metric that is often used is something called diversion ratio. What that means is if you change the price of the first product, where is my demand going to go? So in a merger case, if I actually, because of the merged parties, if you change the price of one or the other, if I increase the price, I'm going to lose some customers because of the price elasticity. Where do they go? So if you sum the bottom row up, it has to equal to 1, which means that the consumers that I lost, what percentage of those lost consumers are going to go into your competitor product is what this matrix is going to tell you. Off diagonal is always important for these ones. So off diagonal here is going to be the consumer that you're going to lose out of the market, what we call outside option. So if you merge and if your utility is not good enough for the rest of the available product, you're just going to get outside of the market and not buy anything. So those are the purchasing decisions that you're outside of the market. So this is used to make decisions for the competition authorities and say, okay, if you merge, this is what's going to happen to the market. Your consumers are going to behave in whatever form they were ending up showing up. And then what does that mean? Does that mean that your consumers are going to have a higher price, or where are they going to go? Are they going to not buy anymore? So off diagonal will be important there. All of those things are going to be important. So a recent case that I was working on was trying to figure out how close two firms are. So these are, let's say, product 1 to 5 is sold by one firm, and 6 to 10 is sold by two firms. By looking at the quantification of these two, you get to see how close they are. If they're really, really, really close, then competition authority will be probably less likely to approve their merger decisions. If they're really, really far apart, maybe it's okay. That all depends on the market decision. So this is a good time for me to talk about our data scientist's role in this huge thing. So we work with lawyers, we work with government, we work with competition authorities, we work with firms. So a lot of those people are trying to make a decision about merger. We go in and we do this analysis, but a lot of the times we have to explain what this analysis to the judge and to the other people, so that's a big part. So if you do end up being interested in our firm, you will have to work with a lot of other people as well. Okay. Detecting cartels is another case example that I have brought today. So cartels there are some famous cartels in Netflix and other places, but those are not the only cartels that we get to see. So cartels are generally defined as any agreement or controlling or manipulating of the competitive market field. So if you do price fixing, that would be considered as a cartel. So legally, you can make a case about cartel if you're price fixing. If you production quota, meaning if you reduce your production, then you can make a legal case about that. And if you have any agreement that is anti-competitive, technically it doesn't have to be a cartel, but you do have an anti-competitive case that you can make. Why is that important? So from an authority's perspective, if you do have a cartel, normally the end customers suffer a very higher price, and then there's going to be lack of innovation because there is some barrier to entry. and detection of the cartels and thinking about the counterfactual analysis, because you've always had the cartel. So thinking about, like, if you didn't have a cartel, what would be the market setting is an interesting question. And that would estimate the damages. Because a lot of the cases, what happens is there was a period where there was a cartel, and then there is a case against the cartel. It's like, hey, I actually bought your product at a very high price. I think this is how much the damage should be. But in order for you to calculate the damages, you need to create a counterfactual scenario where if you were competitive, I should have gotten this price. But I didn't, so this is how I'm going to estimate the cartel damages. So what we do is we do this estimating damages or quantum damages cases, and then we help them get compensated, hopefully, or at least fight to get compensated there. So there's two parts to this cartel cases a lot of the times. One is detecting the cartel, but in the legal cases, there is a system in place, the game theoretic system in place, that if you were part of the cartel, and if you're the first one to tell, I think you get some kind of benefits out of it. So sometimes you don't have to actually prove the cartel. It could actually be very obvious. But if you do actually have a cartel already proven, then we go into estimating damages and counterfactual. We're going to talk about counterfactual in the third case. So right now, I'm going to talk about how do you detect the cartel in normal cases. Again, data generating process is a key word here from a data scientist's perspective, because the idea about the cartel is that there are usually factors that's determining prices. It's going to be demand-driven, it's going to be supply-driven, it's going to be some other market setting-driven, but we kind of know how the price is being set in a normal cases. If this data generating process doesn't explain in some period, so in other words, if this epsilon is not mean zero or deviating from a normal data generating process, we kind of consider that you are outside of the data generating process for that period. We don't know why this period is all of a sudden high. So that is a empirical evidence to go investigate a bit further. So what we do is we first need to have a really good idea about how the price is being set. So what that means is we need to talk about the experts in that firm. So today I brought a pasta cartel case. But so then what that means, we need to talk to the production team of the pasta, how do you, or the C-suite level of the pasta, and then we can talk about it. And this is public case. You can, it's a paper, academic paper. You can go see. This is the source code for it. Okay, so there's some details about, like, for the prices, because the change is what matters, and the stationarity you need to kind of control for the first differences. And then the functional form can differ quite a bit, but we really like linear ones because there's a lot of analytically already solved properties that we don't have to deal with. So ideally, if you can do like some kind of what this is called Cobb-Douglas function, where you log it and you can become linear, any kind of analytical solution that you can make it into a simpler linear format is preferred. But if the price is actually determined in a much more complex way, then you need to follow that. Right now, we're going to talk about a very simple case of Cobb-Douglas assumption where you have demand-driven, supply-driven kind of factors, and then it all gets into some linear form for now. Okay, so the price is determined by something called exogenous supply shifter. So in the pasta case, there is something called durum, which is like a wheat, I think. So the wheat price, which is a key input cost, is important. Labor cost is important, and energy cost is important. So all of those kind of supply factor goes in as a CT, and C is standing for the cost a lot of the times. Demand is also important for the pasta, so household expenditure, like how much are you willing to pay for the pasta, depending on the time. Cost of living crisis happens, and then you have to consider for it, so those kind of go into as a demand shock. And there's particular market characteristics that you need to think about. So if you don't have huge data, you might have to aggregate across different geography. Then you need to control for the geography. And there's or if you have competitors, you have to control for the competitors. So those other market settings go in as an ST. So this is pasta, the difference in the pasta price. So it's this part. delta of PT over time looks like this at a different geography. You can kind of tell that there's something happened in 2007, 2008, but you don't really, by just looking at it, you don't really know whether it was a cartel or GFC happened during this time. There's a lot of stuff that could have happened during this time. This is why the data generating process is important, because all the things that you think that could have happened that drove these changes, you need to control for it in your model. So if you do control for it in this model, this should be close to 0. So what that means is that, so if you just plot the epsilons, it should look like 0. And then all the other things that's driving behind, maybe because of the labor prices or expenditures, cost of living crisis, blah, blah, blah. So in this particular example, the supply factors that were considered was the input costs, so domestic Durham price, international Durham price, labor cost, energy cost, borrowing cost. For the demand, the best data that was available was household expenditure around that time, so we used that to control for willingness to pay for the household. But you can replace that with much better data if you do have it. So how do we detect it? This is kind of how we think about it. We like doing OLS because there's a lot of information that we know from mathematical equation about the error term if we use OLS, so we're going to go with OLS for now. So we estimate OLS regression, which is the delta P equals the supply and the demand. You calculate the residuals, and then you sum them up. Because epsilon, if you understand the data generating process very well, your epsilon should be 0 all across. So you're summing them up to see when you started seeing the differences. And then you set something called critical values. This is probably for data scientists, is probably something along the line of hyperparameters / we sometimes use expert opinions to set the prices. What is the critical value where it deviates a lot? So you get to set those critical values, and then you interpret. This is base case. We also use something called MOSUM. MOSUM is moving average component. So this is on top of not just detecting the cartel, you can also detect the cartel by looking at different periods. So we kind of a lot of the times use MOSUM test. This is what we brought here. So as you can see, this is empirical fluctuation process, and the equation shows that it's a sum of epsilon over different times that you're going to see with some adjustments. And then you can see that on the off-cartel periods, that sum of the moving average errors are around 0, should be mean 0 if you have good data generating process. And you can kind of tell that this is the cartel period, where the price, during that period of 2007 to 2009, you can't really describe that jump in the prices. I don't know what happened. So then what happened? And then you started looking at the legal cases and all the other things. If you want to go a step further, you can use other algorithms to actually detect exact period, because that's going to actually be important. Because if you were 1 more month cartelled, that means your damages increase. So there's a huge impact on figuring out what period the cartel was. So you can do that here. OK, so last case is something that is kind of like digital related, because I wanted to bring something digital related. So it was a case in the US where it's an anti-competitive agreements case. So what happened here is that it has been public information. There has been some agreements amongst the firms to kind of do an activity that's anti-competitive to the market. What that means is, I will talk about it next, but then those agreements actually ended up potentially harming customers by increasing the price or reduced the innovation, or in this case, it also reduced the information that the consumers are having. So it's not just the damages in the price, it could also be the damages in the information. And then you could have a poor quality on goods and services. If you have lower information about the product that you're buying, you're likely to buy a lower quality product, blah, blah, blah. So how do we determine, actually, the anti-competitive agreement in this case was determined, but we are providing additional empirical evidence And then we're also estimating the damage of that anti-competitive agreement in this case. So that's what we're going to talk about. And then we're going to talk about how we can, data science can help in this case. So the background about this case is that there was a company called 1-800-CONTACT. It's the biggest contact provider or seller in the market. And they were having a contractual agreement with other lens selling, so contact lens selling firms on the online bidding. So if I am 1-800-CONTACT, and then I'm having an agreement to the second or another competitor named Vision Detect on online space, advertising space, I'm actually negatively bidding on Vision Direct. What that means is if Vision Direct is searched, I'm not going to be shown on yours. Another way around is that if some customer is searching 1-800-CONTACT, I'm not going to see Vision Direct. So you're actually reducing the ad appearances. So that agreement has been revealed. So then our job was to, not our job as like economist job, is the amount of information available to customers limited, is the first question. So that's going to be thought through thinking about counterfactual layout of ads. If that agreement weren't in place, what kind of advertisements would I, in terms of consumer, have gotten? If, given the counterfactual ad layout, was the price higher to the consumer? So that's a direct monetary damage impact, and that's what we're going to look at today. So, thinking about what ads would have been displayed if that agreement hadn't been in place is kind of an interesting question. And we can have a discussion about the validity of this method all along, and that's going to be that litigation process. But in this particular paper, they were talking about using genetic searches. So instead of searching for 1-800-CONTACT or Vision Direct or any other competitor, because all of them are in the agreements, let's kind of do a generic search term. And that generic search term is like contact lenses, cheap contact lenses, or something along the line that doesn't have a competitor's name or any seller's name. The reason that this is important is because it's probably how retailers buy. And also, this was not restricted. So it's very important to look at the non-restricted firm to do the counterfactual. So some more details about how you set up that counterfactual is for each search for the 1-800-CONTACT, you count the number of ads in the main 4 positions. So how many ads were there? And then you look at all the generic searches, like contact lenses or all the other generic searches. And then if 1-800-CONTACT was there, you're using that as one of the counterfactual scenarios. And if the advertisement is as many as what you would have searched in the 1-800. Those things are all there so that you are creating the counterfactual advertisement space as close as what you would have searched if a consumer were to search in Vision Direct or 1-800-CONTACT. So those are kind of conditions for us to kind of set that together. Now, for each of those match generic searches, if 1-800-CONTACT was not in, you just put it at the top, and then you reorder them. And then in the ad spaces for this particular thing, the ad was only top 4 ads, so you kind of reorder them so that 1-800-CONTACT is appearing. The reason for that is they were subject, and the second 1-800-CONTACT is the main driver. So if you were to search for the contact lenses, they would have appeared. And then you repeat for all observed searches for 1-800-CONTACTs. So if you have done that and then looked at all the searches and then replace all the searches that didn't have 1-800-CONTACT, replace them at the top, and then you look at what's happening here. So by construction, then the counterfactual scenario, 1-800-CONTACT ads are going to appear, because if it's not there, I'm going to put it in, right? Compared to all the other genetic searches, like normal data, 99% of the times they did appear because they are the main driver in the market. You do that same process for all the other competitors, and you look at how many of those competitors are going to be searched in the ad. And then here, the main metric that we should be looking at is like the data says they're in total, the impressions that you're going to get is much lower compared to when you look at the counterfactual. So counterfactual is if the agreements weren't there, what would have happened? If agreements weren't there, this analysis shows that your ad would have appeared probably 3 times, no, almost 4 times, like 3.5 times more often, because it's comparing 53 to 182. But this is just appearing on the ads. Does that mean that it's going to actually add to the sale, or is that going to connect to the sales and stuff? That's a different question. So then we need to think about click-through rate. So that's phase 1. Phase 2 is, once we know what the counterfactual is, let's think about the click-through rate. So we build a click-through rate by looking at the position of the ad, whether you would search for the particular firm, or whether it was search for 1-800, or which firm it was, the brand valuation, kind of thinking about what are the factors that determines the clicking through the ads versus not. So these are the data generating process that this case has been thinking about. And if you do that, and think about the click-through rate in a counterfactual scenario, using the data that we created as a counterfactual, so we have the data on the counterfactual searches, you do see that the number of clicks has increased by 3.5%, 3.5 times, actually, it's much bigger than that. So now we have counterfactual searches, now we have impact on the click-through, and then now we connect that to the price. So there's some assumption that goes in, because this is not a very well-streamed process, we don't have data for all of this. So what we do have is data for the contact lenses, like this is particular product. So a Cube is one of the best-selling product, and price for this particular product at different competitors or different firms, this is the information that we have. Using this, and using the counterfactual versus observed data, what you do is you compare the price impact by dividing these firms into 2 groups. First group is the firms that are in the restricted search, and then firms that are in not restricted search. What they mean by restricted search is if they have an agreement with 1-800 contact and that you're not going to be shown in the ad, you're in the restricted search. If you're in the firms that are under unrestricted search, what is your price? If you see that, there is a clear difference in the price. If you are in the unrestricted search, your price is lower. So from consumers' perspective, if that agreements weren't there, the price would have been lower by this much on the last column, the differences. So for the Cube lenses, in the restricted search area, which is a counterfactual scenario, the price was about $22. But if the agreement weren't to happen, then it would have been at around $20. So this is kind of bringing a lot of analysis together to get to the kind of quantum estimate of the damages in this case. And this was an FTC decision, I think, a few years ago against this particular case. It's public, the paper is public. Welcome to go search for it. Okay, so I've talked about 3 cases today. One is mergers, one is cartels, one is anti-competitive agreement. The third one is to just kind of show you that it's not just this particular 2 cases. It could be any civil lawsuit where you need to calculate the damages. We could be helpful there. And the impact is, normally what we're looking at is consumer welfare. It could be usually the price, but now it's increasingly your attention, your information, and other things. And then innovation in the market is very important. So if the market keeps not innovating, that means the market itself is not competitive. We want to make sure that that happens. Last one is better functioning market. If you're a small firm, are you able to enter very easily? What is the barrier to entry? And then what is the price setting? All of those are something that we're looking at. So we are always wanting to work with some other smart people. So if you are interested, let us know, or talk to me outside. Good.
Thanks, Minyoung. Has anybody a question they'd like to ask?
Sorry, on the lenses.
Yep.
Just
Sorry.
Oh.
Just little bit of the context. What was the genesis behind how this actually transpired? Were they just naive about anti-competitive behavior, or do you know the context that?
I don't know about the naivete of the case, but what happened was the agreements between the lens company has been brought to attention to the FTC, which is Federal Trade Commission. So they are the police for anti-competitive government, so they wanted to investigate the case, and they particularly wanted to look at the advertising space. So what is the impact of advertising in an anti-competitive space? So this was, the one side is FTC, the government, and then the other side was 1-800 Contact. So the 1-800 Contact was the main, I think their market share was quite high, and all the other players were smaller. So another tension there was that if you enter into that agreement, does that asymmetrically influence the price of, or revenue of the 1-800 Contact as opposed to smaller players was another one. So it's a bigger case, I think, but I just brought one small case. Yeah, happy to share the link to the case. Yeah.
Thanks. In the second case, how do you sort of control for legitimate price discovery?
Meaning, how do you get the data generating process of the price?
No, I mean, if it's you know, shop A sees shop B across the street, it will adjust its prices naturally and legally. So how do you sort of control for that? Because they might not be in a cartel. They might just be sort of naturally discovering prices.
Sure. So if that's the case, that maybe location would be one of them. So that's a really good question. So this is probably most of our time is trying to figure out how does the price get determined. So if shop A's price is higher, we need to figure out why they're higher. So if it's higher because it's closer to the train station, we control for the train station. If it's lower because of the different reasons, then we control for other things. A lot of the cases, if the data is large enough, the kind of effects gets meaned out a lot of the times too. So that could work, but good question. There's no answer to that. We talk to a lot of people, and then we do a lot of running the models to make sure that the error terms are not there. Mm-hmm. Oh, none of these cases are actually, these are all public cases. We work on different cases. Happy to talk about things that I know and I can talk about, but these are public ones, so we didn't work on it. I just wanted to make a disclaimer on this. Mm-hmm.
Just wondering, how do you determine thresholds for statistical significance? Do you exercise like discretion case by case, or is there like minimum thresholds that you have to meet with every case?
Case by case. So there are some statistical rules that you can use, but sometimes you do have to do a lot of sensitivity analysis and robustness checks. So if that statistical analysis is weird, and if the kind of the stakeholders think that that should be another significant threshold, we test that out too. And then we come up with some robust way, like during this period, we are 100% sure that this was cartel. During this period, we don't really know. Yeah.
Can I ask a follow-up question?
Of course.
Yeah, how is that regulated? I guess you've kind of answered that, but is there like an external person, or is it someone like internally who regulates that?
It's mostly, you tell me if I'm wrong. We have a colleague here. And mostly it's civil cases, so it's decided in the court about what happened. So somebody in a cartel case, or if cartel's already been defined, then the person who's been harmed sues, and then they decide on the amount and the period and other things, and then they come back. You have something to add? No. Yeah, so those are the, mm-hmm. Yeah.
Hey, thanks. Super interesting talk. I had no idea that this kind of modeling happens in these situations, like litigation, etc. So yeah, really kind of eye-opening. Thank you. I guess the models that we use, I work in like financial crime prevention. We have to like show them to a regulator and explain them. And actually, half of the challenge that we have sometimes is explaining the complexity of what we're doing and justifying it and getting the regulator on board. It feels to me like you're doing some really complicated, complex modeling there. Mm-hmm. Is one of the challenges for you actually getting the judge on board with like the modeling approach you're using? And how do you tackle that? Because these models seem like quite custom, like quite complex. Like.
Yeah, no, absolutely. So one of the kind of competency that we try to excel at is explaining stuff. using other things. So I think there's two questions about that. So one is replicability. And the other one is, once you know what the model is and it's replicatable, then can you explain it? We focus a lot on replicability. We have a very kind of well-seasoned process of auditing. We have a very particular framework so that we can communicate with the lawyers and the judges in a particular way. And so replicability is, so this is one of the reasons why we are very conscious about using models that doesn't replicate. So I think a lot of the LLM models or a lot of the models that you would be probably using in a fraud detection probably is not like that, in which case, what are the other ways of explaining what you want to explain in a deterministic way with some error that is also determined. And the other side is, okay, these are the things that we need to explain. What is the best way to do it? And that's a whole nother challenge that some people at our firm are really, really good at that I'm learning a lot from. And so visual is very important. So this is the format that we have is a new visual identity. So we spend a lot of investment on trying to explain stuff to different stakeholders.
I'll just ask a question about cartel detection. If you have a cartel where they agree to sacrifice price at one of the members of the cartel and give them a backhander, can you detect that? So you basically set up someone to make it look like there's a functional market, but you give them money to compensate for their lower profits.
Statistically, I don't know a case yet. So I think it's actually a good time for me to explain a bit about the cartel or the work that we are involved in. So cartel detection, in the legal side, there is this placement in place where if you were in a cartel in any period of time, if you're the first one to report, basically prisoner's dilemma. If that's the case, there's a case for it, in which case it's very easy to look at what agreements, what data, and at that point then you can do statistical testing if you have an idea. But detecting that information out of all the information you have is going to be very hard. I'm not aware of it. That doesn't mean that it doesn't exist, but I'm not aware of it. The other thing that I want to mention is that a lot of the cases are actually estimating the damages because a lot of cases are brought on already knowing that the cartel, or already having a very high probability of cartel already existing. So if you have an idea, then we can kind of search for it, but there's the other side of that comes in.
Right, looks like we've reached the lunchtime threshold there. So let's thank Minyoung again. So there's hot lunch outside. There are two counters. There's one this side and there's one the other side of the central course. So please find whichever one's quicker.
Thank you.